In this session, we will discuss a simple model of classical theory of employment and output determination. We will develop classical theory of employment and output determination in the next 4 or 5 sessions. Now, there are 4 main theoretical components in the classical system. 4 theoretical components in the classical system. The first one is a theory of production. A theory of production. The first component is a theory of production based on law of diminishing returns. Based on diminishing returns which links product market with the labor market. Theory of production based on diminishing returns which links labor market with the product market. Second, a classical labor market. A classical labor market. Second component, classical labor market which determines real wage and total employment. Classical labor market which determines real wage and total output. A third one is a theory of saving and investment. A theory of saving and investment which introduces the role of interest rate as a equilibrating mechanism which ensures that aggregate spending is always equal to aggregate supply. So, a theory of saving and investment which pinpoints the role of interest rate which ensures that there can be no spending shortage and there is no overproduction of goods and services to generate a crisis. And the fourth ingredient is the quantity theory. The quantity theory of money, and this theory is used to explain the price level. And as we will see later, money stock will not have any effect on the values of real variables. That is what is known as the classical neutrality proposition. Money is neutral in the sense that it cannot affect the values of any of the real variables. So this neutrality proposition ensures that the level of real output is independent of the money supply. The level of real output, that is output of goods and services, real terms, not monetary terms, is independent of the supply of money in the economy. So the question is, what determines real output? What determines real output? So to explain what determines real output in the classical system, we first introduce a key component of the classical model, namely short-run production function. A key component of the classical model, namely short-run production function. In the microeconomic classes, at a micro level, a production function shows the maximum amount of output that a firm can produce from any given amount of factors of production. So if the factors of production are capital and labor, the short-run production function at a micro level is written as Q is a function of K and L. It shows the maximum quantity of output that can be produced as functions of factor inputs. And if we use more amounts of factors capital and labor, there will be more output produced. And in the short run production function, it is assumed that the amount of capital K, in the short run production function, it is assumed that the amount of capital K, state of technology, and also population is assumed constant. Level of capital, state of technology, and population assumed constant in the short run production function. And output is varied in the short run by variations in the labor input taken from the fixed population. By increasing the labor supply or by reducing the labor supply, keeping capital technology constant, it is possible to alter the level of output. This is what we have learned in the microeconomic classes. In the macro level, we consider the economy as a whole, where we consider aggregate outputs Y, or what is known as GDP. At an aggregate level Y or GDP, output of the economy as a whole is a function of the amount of inputs used, and this is known as short-run aggregate production function. Short-run aggregate production function, which is written as Y is equal to A into F of KL. Short-run aggregate production function for the economy as a whole is written as Y is a function of A into F of KL, where Y is real output. Real output means output of goods and services in real terms, not in monetary terms. A is known as index of total factor productivity. A is known as index of total factor productivity. Actually, it is a factor representing technology, and F is the function which relates capital and labor to Y. And in a broad sense, A, total factor productivity, represents an autonomous growth factor which captures the impact of improvement in technology and also any other influences which increases the overall effectiveness in the utilization of inputs. In simple terms, we can consider A as a factor representing technology, and its name is total factor productivity. This component is very important when you study the growth models. You will study how to estimate the contribution of total factor productivity, etc. Anyway, this is the aggregate production function, which is a key component of classical theory of income and output determination. Now let us see how this short-run aggregate production function is depicted graphically. Now, we depict the short-run aggregate production function like this. Now, we take Y here, L here, total product of labor here. Here MBL is taken, L is taken, this is MBL, L1, L2, level of utilization of labor input. Now, short-run aggregate production function is depicted in the first half. And let us see what are the characteristics of this short-run aggregate production function. As you can see, at low levels of labor usage, that is up to OL1 level of labor usage, it is a straight line. It is a straight line. And slope increases, as you can see, up to OL1, slope remain constant. Now, this portion of the short-run aggregate production function, for avoiding confusion, I write it as Y is a f of Kl, is characterized by constant returns to the variable input L, not a constant returns to scale. Up to OL1, short-run aggregate production function exhibits what is known as constant returns to variable input L. That is OL1 level of output. But you see, this is a peculiar situation. In the microeconomic classes, the short-run production function is not drawn like this. Short-run production function is drawn in such a way that it increases at an increasing rate, at a diminishing rate, then decreases, so that the slope of the short-run production function, delta Y by delta L, that is MBL, initially increases, then diminishes like this. This part is consistent with the characteristics of the economy during Great Depression, where there was considerable amount of unutilized labor resources. So, if labor usage increases, then returns, that is the contribution, the marginal product will remain same. But for most part, we consider the section L1, L2, where as labor input increases, the short-run production function is concave. That is, it increases at a diminishing rate. So, this portion describes or exhibits diminishing returns to the variable input L. So, between L1 and L2, marginal product of labor, that is the slope of the short-run aggregate production function. The slope of the short-run aggregate production function is downward sloping, and beyond OL2, as you can see, the addition of labor causes decrease in output. So, this is the short-run aggregate production function used in the classical model of income and output determination. And part B shows what is known as the slope of the short-run aggregate production function, delta Y by delta L, which is nothing but MBL. That is, MBL is the slope of the production function. Now, in the area of constant returns, as L increases, MBL, the slope is flat. MBL is a constant. As more workers are hired between L1 and L2, as you can see, slope is what to say? Slope is negative. Slope is negative. That is, MBL decreases. Eventually, MBL itself is negative. So the short-run production function, the first ingredient of the classical theory of employment and output determination, is a technological relation that determines the level of output given the level of labor input, keeping constant capital, technology, skill level of the labor, etc. But this production function will shift upwards if there is an increase in the amount of capital used, if there is a technological improvement, etc. These are points which we will discuss later. So equation 1 is a relationship between inputs and outputs. That is y is equal to a f of k and l. But this equation and this graph which represents this equation tells us nothing about how much labor will be actually employed, whether it is OL1, OL2 or somewhere between these two or beyond OL2, etc. In order to determine how much labor is actually determined, what determines the level of employment in the classical model of income determination, we introduce the classical labor market. We will do it in the next session.